Okay, welcome to Investigation 3 in our Saxon Math series. Investigation 3 begins on page 131 if you're following along in your math book. And in investigation, we further investigate certain mathematical ideas or concepts. Now, today's investigation is actually going to be done over a 3-day period if you're in my classroom. And there are 3 learning targets. The first one is multiplication patterns, which we're going to focus on in this video. Then the second day, we will focus on area, which is another form of a multiplication pattern, and then squares and square roots. All 3 of these concepts have to do with multiplication. So you're going to hear that word over and over again, and that should already be a power pick on our wall. So let's get started. Let me change to a highlighter. Now, one model of multiplication is a rectangular array. Now, you might be tempted, let me just stop right there, and you might be tempted to think, an array, didn't we learn that in geometry? Well, you did. In geometry, array has a starting point and it's a straight line that goes on forever in the direction of the arrowhead. That's called array, R-A-Y. But when we're talking about multiplication, not geometry, but multiplication, we have this word, array, and it's got these 2 little extra letters on it in the beginning, and sometimes it's hard to hear if people say it too quickly. But an array is a model of multiplication. It's a picture of a multiplication equation. And here we have an example. This part that I am outlining in red, this is an array right here. And you see they just used a picture of stars. And they have them patterned or lined up in a certain pattern. They have 3 rows, and the rows go across from side to side horizontally. And then they have 5 columns, and the 5 columns go up and down vertically. And this probably reminds you, if you're in my classroom or another whole brain teaching classroom, this probably reminds you of our power pick walls, because those power picks are arranged in an array. And that's why, because that's just another way for us to teach you about an array. So this array right here, the array with all the stars in it, it has 3 rows and 5 columns. So we can represent that as 3 times 5 equals 15. This array is a picture of this number sentence, this equation, okay, where 3 is one of my factors and 5 is one of my factors. Let me show you an example of some more. Let me go to the next page. Here I have some others. Let's see. Here's 1, 2, 3, 4, 5, 6. So here's another array of stars. And if you were going to write that array as a multiplication pattern, what multiplication pattern is shown in this array? Well, we have 1 row and 2 rows. That's 2 times 1, 2, 3. That's 3 columns. 2 times 3 equals 6. Okay, here's 1, 2, 3, 4. And what is shown in this array? Well, you have only 1 row, but you have 1, 2, 3, 4. You have 4 columns, so that's 1 row times 4 columns. 1 times 4 equals 4. That's the multiplication problem shown in that array. Here we have 1, 2, 3, 4, 1. I love the infinite cloner. Makes things so easy. What multiplication pattern is shown by this array? Count your rows. 1 row, 2 rows. Okay, that's 2 times 1 column, 2 columns, 3 columns, 4 columns. 2 times 4 is 8. And if we were to go back and count these x's, we would find we have 8. 1, 2, 3, 4, 5, 6, 7, 8. So 2 is one factor and 4 is the other factor. And finally, let's practice with these squares. 1, 2, oop, gotta really grab it if you want to clone it. 4, 5, let's go for it. 6, 1, 2, 3, 4, 5, and 6. So how many do I have? I have 2 rows, 1, 2, that's one factor, and I have 1, 2, 3, 4, 5, 6. That's the other factor. So 2 times 6 equals 12. And if I go back and count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I do indeed have 12 squares in all. Now the really cool thing about an array is you can take them and you can rearrange them. If I wanted to, let me erase this giant eraser. There we go. If I wanted to take these and I wanted to arrange them like this, just move them around so that I had the same number. This isn't very straight. Let me straighten this out. There you go. Get nice and straight. Notice I have the same number in each row and the same number in each column. That's very important. It's not an array if it's not perfectly equal with the same number in each row and the same number in each column. See, I have 1, 2, 3. I have 3 going across in each row. And I have 1, 2, 3, 4. I have 4 going down in each column. Okay, that's what makes it an array. If I got rid of one of these, like let's get rid of this one. Let me cut that guy out. If I got rid of this, this is no longer an array. Okay, this could be an array right here. This part could still be an array. And then I would have 2 extras that were not part of my equation. Let me clear that ink. And let me go back and put that guy back in. Yeah, that's what I wanted. Now, see, I took those same set of 12 squares, but now I have a different pattern. I have 1, 2, 3, 4. Now I have 4 rows. 1, 2, 3, and I have 3 columns. So now my equation is 4 times 3 equals 12. So sometimes you can take shapes in an array and rearrange them into a different pattern to show a different multiplication equation. So that concludes our first lesson about multiplication patterns and using an array.